So today I want to introduce you to the lathe. Out of all the machines, so you're gonna have to excuse me. I'm gonna look at my phone, not because I'm on it, but because I'm gonna see what the camera is capturing. You can see that, all right? Okay, so out of all the machines in the machine shop, I am particularly fond of the lathe. You will see throughout the semester, I'm going to show you stuff on the lathe that's not textbook for sure. Show you stuff that is textbook, and I don't know how to say. I am one with the lathe. I love using this machine, all of them. This is an old LeBlond lathe from the 60s. It's still in pretty good shape, actually. Yeah, it's a little bit dirty. Up on top over here, up here, I know it looks messy, but it's actually not. These are all the tools that I use throughout the day. But we're not going to look at that until later, and I'm going to show you my tooling, standard tools, textbook tools, tool holders, all types of tooling for the machine. There was a time when I did like you to memorize the parts of the lathe, but I don't do that anymore because it got in the way of actually learning how to use the machine, believe it or not. I know that sounds contradictory, but I found that it did. And for those of you who do enjoy this as much as I do, I think that you're going to be inclined to find out the parts on your own. Okay. Yeah, cheers. I've got my espresso here. Yeah, I got these new fancy metal cups that I like to use in the shop in case they spill, you know. Yeah. Okay. The parts here, I'll go over, take this out. What I do want you to know, okay, and we're going to go over this machine right now. What I really want you to know is that this, hang on, let me put this here so I can see it. This is this whole assembly here that moves from side to side like this. See that move from side to side? That is the carriage, okay? This right here, this that spins here, this is the chuck, okay? This is a 3-jaw chuck. For the time being, just ignore the aluminum soft jaws that I have in here. I'll talk about those, definitely. But for the time being, I just want you to ignore that. The chuck these are the jaws. They just happen to be aluminum. The chuck is attached to what's called a spindle. And the spindle is what's attached to the gears that drive the spindle. And the gears, of course, are attached to an electric motor. The electric motor drives the gears at a certain speed. The gears drive the spindle, and the spindle drives the chuck, and the chuck is what holds your material. And I'm going to show you how to put material in there in a moment. So this is the chuck. I want you to know that, okay? This is the carriage. This is the cross slide. Here, see that? This is the cross slide. It moves from back and forth. The carriage on this wheel moves everything this way. I'm not even going to use the correct terms yet. This right here is called the tailstock. Okay? Yeah. This wheel moves this ram in here, in and out. This lever locks the tailstock to the lathe. I'm not even going to go into the parts. These are called ways, but I'm not even going to, we're not going there. And this locks the ram. Okay, so it won't move. Okay. You're going to see a lot of levers on here, and at first it's intimidating. This is the material I'm going to use. Okay, it's intimidating, but believe it or not, it's not intimidating. It's not confusing at all. After I break it down, it's going to be actually rather simple. Okay, but before I do that, I briefly went over an overview of I just showed you what a lathe is. I mean, really, that's all that I did. But today I'm going to show you more in depth about what the lathe does. Okay. The chuck, and this is the chuck key. It goes. The drive, the key goes into this scroll here. I'm using fancy words. I know that. I like to just call it straight up jargon, but it is okay. So this is going to tighten the chuck, and because this is a 3-jaw chuck, it's on this scroll. So if I tighten it, it just moves the chucks, all 3 of them, in and out together, just like the chuck on a drill press. Okay, and there's a location, a key insert on 3 spots here, so all the way around. And you only need to use one, just like I showed you on the drill press, right? We don't need to go around all the chuck keys. Okay. This is the material that I want to put in the lathe. It's a piece of 1-inch aluminum, okay? And so let's put this up here. Now, one of the first rules about the lathe is the chuck key is either in your hand, turning the chuck, tightening or loosening your material, or it is outside the lathe, not in your hand. It's either in your hand, all right, tightening or loosening the chuck, or it's not in your hand, away from the machine. The only way, not the only way, but really one I don't know, I'll just say it, okay? This spins. Put material in there. All right. That's about it. You don't need to crank on it, okay? This is the on and off lever right here. Okay, so I'm gonna just turn this on really quick. You're not supposed to turn the machine on without material in the chuck. Because of centrifugal force, it can move the jaws out on you. All right, so that's why I put this. So let's just turn it on, and you can see it rotate. Okay. There's another habit that I do. So now it's on. Okay. All right. So rule number 1. If this is in there and I turn this machine on, what's going to happen? This thing is going to come flying out and hit you in the chest or somewhere, okay? Which is bad, obviously. Or it's going to come down and it's going to crash into the machine, okay? Most likely it's going to fly out, all right? Right at this point here and come hits you in the chest. And when it does that, hits you in the chest, you ever had the wind knocked out of you before? Well, if you have, you know what that feels like. So basically, this is going to come out, hit you in the chest, and you're going to hit the floor. And then you're going to be, you're going to have the wind knocked out of you, and you're going to be lucky if you don't have any broken ribs. How do I know that? Yeah. I've been doing this, like I always say, and I know you're probably like, shut up, dude, for a long time. And if you've used the lathe a couple million times like I have, eventually it's going to happen. Yep. Chuck keys come out, hit me right in the sternum. Next thing I did was hit the floor. Wind knocked out of me. Okay, lucky I walked away with no broken bones or any major injuries. Okay, fortunately that did not happen here at the school. But I just want you to know how serious that can be. So the chuck key is either in your hand, tightening or loosening material. Okay, tighten, loosen, tighten, or it's out of the machine and not in your hands. I hope that's very clear. Okay. Of course, safety glasses. I don't need to say that. I don't think that's pretty obvious. The other thing I want you to get in the habit of doing is, I don't know if you've already noticed me spin this. Okay. I'm spinning this, and with my left hand, I'm right-handed, and I'm constantly spinning this. When I take material in and out or use chuck key, I'm just constantly spinning this. Why? Because there's going to be times like right now where I'm up really close like this. Okay, bam. All right, and if I do it by hand, nothing bad's going to happen. Okay, if I turn on the machine and that happens, you can already see here that somebody, it wasn't me, this machine's from the 60s, it's been around forever, someone has done that. Okay, that's just from me right now, I think. Yeah, that's just from me slamming it with my hand. All right, which is probably not good for the machine. Okay, move this out of the way. Another rule with the lathe is what do you think is going to happen if this is out here and I turn it on like this with no support out here? Okay, that's a really bad situation too. So the general rule, which actually we break from time to time, I'll just be honest with you, is that the general rule is it's never sticking out more than twice the diameter. So this is about 1 inch material, so that means that I don't want it to stick out more than about 2 inches. All right, so I'm gonna go ahead and put this back in so I can demonstrate what's going on with all the levers and turning it on and off and all that. Okay, so I'm just gonna put this in. Notice it's about just a little over 2 inches in here, and I'm gonna give it a spin. So I'm not gonna what's called crash, bang into something. Okay. To turn on the lathe, this particular lathe is a lever right here. Okay, it's right here. That's right there. Up is going to go counterclockwise. Down is going to go clockwise. The parts of the lathe are labeled forward, reverse, etc. That's fine, but I don't like to think of things in forward and reverse. I like to think of them in the direction of cut, because the direction of cut is forward, as far as I'm concerned. Okay, not what the machine says. There happens to be another on and off lever right here. Right here. See how they're tied together? You can see the other one moving a little bit. Try that over here. See, they're tied together. Okay. The reason why that there's two is because these machines are designed to turn it on over here. You can see that. I'm going to go up, right? It's on, off. You can see that they're tied together. The reason that there's two levers is because these machines are designed to be used in manufacturing. And believe it or not, on an 8-hour shift, the movement to go over here and turn off the machine and then come back over here is not only a waste of time, which in manufacturing they care a lot, but more importantly, it's a waste of energy for the operator, okay? So that's why there's two levers. All right, so let's ignore this lever right here for the time being. This lever is for threading. It's called a half nut. Don't even worry about it. We'll discuss it when we're threading. Just ignore this lever altogether. It is for threading, okay? For making threads on the lathe. So already we've knocked out most of what's going on here around the carriage, and that is we have this lever here, which moves the carriage. If we turn it this way, obviously, I'll go slow this way, moves it this way. If we go this way, it's going to move it that way, okay? If we move this lever here, it's going to move the cross slide, or where we put our tool here, forward or backwards, okay? Like I said, don't be concerned about the parts, all right? Just understand how it works. This is called the compound rest, and this lever here is going to move this at an angle this way or this way, okay? With this handle here, okay? All right. Like I said, don't worry about this. Don't worry about this right now. I'll show you this in a minute, but just ignore this for like a month. Just ignore it. It's not there. This is the on and off lever, okay? This dial and this, they're tied together. This is for threading. This whole business right here, this is for threading. Just ignore it. Let's look over here. Okay. These levers here are nothing more than a chart. Okay? Everything. It's nothing more than a chart. It's that simple. All right? This chart right here, if you look closely, I hope you can see. Let me get down so you can see that. I think you can see that, yeah. This lever is in white, which corresponds to this white row here, all right? And this lever moves, and in these, what they call detents, okay, here, or here. So this lever is in this column. So currently it's white, this column. The spindle speed, or the chuck, is now going to be moving 351 RPM. That's it. So that means that if I put this lever in blue, and this lever over here, in this column, it says 654. So that means that this chuck and this spindle are going to be turning at 654 RPM. All right? So that's pretty simple. That's knocked out, okay? Not right now. A lathe has what's called a power feed function, okay? I'm just gonna put this in here. We'll talk about this in a minute. Has what's called a power feed function. And so the power feed, what that means is that this is going to move at a certain feed rate, which we are learning about currently, determined by this chart, all right? Let me go ahead and demonstrate that, and I will just cut air while I demonstrate that. So I'm gonna turn it on, and this lever right here is what engages the power feed, okay? Remember, this is for threading, just ignore it. So I'm gonna turn this on, and when I engage this lever, okay, it's going to engage the power feed. Notice that the handle is moving automatically, okay? So that's the power feed function of the lathe. If I pull it out and I push down, it's going to engage the cross slide back and forth. So currently the tool is coming this way now. Okay? All right. If I want the power feed to move the other direction, so if I wanted the cross slide to move that way, all I have to do is flip this lever. Notice it says forward and reverse. Currently it's in forward, which meant in forward, the carriage is going to move this way and the cross slide is going to come towards me. If I put it in reverse, the carriage is going to move this way and the cross slide is going to move that way. All right? Let me show you. Now the carriage is moving this way. I'll disengage it. It stops. Out and down. Now the cross slide's moving this way. Okay? All right. So once again, this chart with these two levers control the spindle speed. This lever right here, which says forward and reverse, which I don't like, changes the direction of the power feed. Just a chart, all right? This chart down here with all these numbers on it, this chart, by engaging this into different rows and columns, so let's see, there's B, all right? B, okay? And if I move this, sorry, it's a little stiff. Move this over here, okay? And into this column, I am going, 92 what? Or 0.0045. Now, it says up here, threads per inch and feeds. Oh, okay. Well, hold on. We notice too that we've got a fine and a coarse. ABC in fine, ABC in coarse. Okay? See this lever right here? Fine or coarse. All this lever does is tell us or engage what actual chart we're in. We can actually say this is two different charts, right? We got one chart at fine, one chart at coarse. This lever tells us what chart we're in, all right? So this lever, A, B, or C, tells us what row we're in, and this lever right here tells us what column we're in. Now, what do these numbers mean? Threads per inch. Well, we know that, right? Remember, quarter 20, quarter diameter bolt, 20 threads per inch. Well, there it is. So we'd have to put the machine in coarse, put this column lever in 20, and put the row lever in C, and then we would be able to make threads at 20 threads per inch. All right? The little bottom number, there's lots of confusion about that. All right. Before I tell you what it is, I want you to know something. All lathes, all standard lathes, unless they have a specialty function, like cutting crankshafts for cars or camshafts or something like that, or pistons or something like that, all standard multi-use lathes are all the same. They're just laid out different. It's just a matter of figuring out how they're laid out, okay? They all do the same thing. They all move from side to side. They all have a chuck. The cross slide all moves, right? You can adjust the spindle speed. You can adjust the feed rate. They all do the same thing. It's just done differently. You'll hear me say this over and over again. Okay, when I walk up to a machine, even if it's a machine in this shop that I haven't used, say, in 6 months, I'm not used to it again. I got to brief myself, and I go through the machine. And you know what I do? I walk up to the machine, I put material in the chuck or whatever type of machine it is, and you know what I do? I figure out and I practice how to turn it on or off, and then I turn it on. So I turn it on, I turn it off. I'm like, okay, that's how you turn it on or off, right? I play with it, and I cut air. Because not only do I want to refresh myself on how to use the machine, all right, but I want to establish a relationship in my mind about when I turn this handle, how fast is that? That's too fast, okay? How fast, when I turn this handle, how fast is the cutter in this particular machine, how fast is the cutter going to move? When I turn this handle, how fast am I going to be moving, okay? So right? I need to establish that relationship in my mind, all right? Okay? It's really, really important. Especially on a machine like a surface grinder that I probably use twice a year, I've got to refresh myself, okay? All right. I mean, there we go. I mean, right then and there, we just knocked out all the levers except for the threading on the main parts of the lathe. Now the tailstock. The tailstock primarily, it has other purposes, but primarily has two purposes, okay? Number one, we can put a drill chuck in the tailstock here, all right? And I can put a drill in the drill chuck. And I can drill a hole in my material, all right? Number one. Number two purpose is, which I'm going to demonstrate today, is I can put this tool in there. This has you can see this taper here, okay? This taper and this spins. This is what's called a live center. The reason why it's called a live center is because this spins. If this didn't spin, yeah, you guessed it, it'd be called a dead center. So this is a live center. It slides in here, and the purpose of this is to support the material. Remember how I showed you if this is sticking out way too far, it's just going to go, right? Well, we can drill with a center drill, like I briefly showed you before, a hole that the taper matches this taper, and we're going to be able to support our material. And I'm going to demonstrate that briefly. Okay. But let's go a little bit. Let's go a little bit more. This is the tailstock. So, okay, it'll move along the ways, along the lathe travel. This is the lock. So, oh, it won't lock. Okay. This moves the ram in and out, and this is the ram lock. So if I lock it, right, it won't move anymore. Okay. Anybody notice anything? Anybody notice how gentle I am? All right. So that whole burly man stereotype that goes along with the machine shop, wow, that's false. Like, wow, that's false. As a matter of fact, the gentler you are with your equipment and your project and the material and the cutting action, the more effective you're going to be, and your project is going to turn out. That's it, you guys. No cranking on anything. All right, watch. That's it. Ready? So this will move, right? Ready? See that? There it is. Okay, not moving anymore. There's absolutely no reason to crank on anything. The gentler you are, the more effective you're going to be across the board. So I'm going to use the word effective, and that means wear and tear on the machines and how well your project's going to turn out. Okay. There you have it. Aside from threading, that's it. So we've demystified the lathe. Real quick, this right here, this is called the lead screw. That lead screw is for threading. That way we can do something called chasing our threads, because we don't want to cut thread profiles all in one shot. We want to cut them gradually, and this will allow us to engage in that same profile over and over again. This rod down here is what controls the power feed, okay? And this is the on and off lever, okay? There you have it. By the way, I have a peripheral device on here. This device right here is for my if you can see, there's a digital readout there. It's quite interesting. On the lathe, I don't use it. I don't use a digital readout on the lathe. I use a digital readout on the vertical mill all the time, and you'll understand why in a couple months. But I don't use the digital readout on the lathe very often, or if ever, for that matter. I just don't. There's no need. I don't. There's just no need. I mean, I guess if you were doing a million of the same parts and you didn't set up a stops and things like that, and your tooling was always changing, I guess that would be a reason. But I just don't do it. Okay. Anyway, so. What is left here is what's going on here. All right. So this and this. This is called the tool post. All right. And if we look closely here at the tool post, I need to get a rag. All right. If we look closely at the tool post, we're going to see what they call a dovetail, and this lever that moves part of the dovetail in and out. All right. And this is the tool holder. This is the tool post. This is the tool holder, and this right here, this piece of steel right here with this point that I've ground in it is called the tool. All right. This is the tool holder. This piece of black steel. This is the tool post. This is the actual cutting tool right here. Okay. They make, and I put one out so you can see it, and we're going to go over all this, but we're going to do it on the board. This is a carbide insert tool, so I don't have to grind it. I just take the insert in and out. All right. There's another one here I grabbed. There's another one. This gold insert right here comes in and out. That way I don't have to grind tools. But we're going to go over all that. I don't use them that often. I just because I'm not cutting. We'll go over it. All right. When we're cutting on the lathe, we're going to be using the tip of the tool. You see that? Just the tip of the tool. Not the sides, not this back rake here. Okay? None of that. We're going to be just using that tip of the tool. And that is why the tool post spins around like this. So if I wanted to cut along the face, also the process of cutting along the face is called facing. I can turn this tool post this way, right? So I can align the tip of the tool to cut, all right? Okay? And the same way, if I want to turn this down, make the diameter smaller, or cut some sort of profile into it, I can turn the tool post like this and use the tip of the tool to run along here, okay? Now, what's important, in this class, we're not going to get into tool geometry, like what all these angles are and all that. That would be for next class, which we don't offer. But what we need to know is we want to cut with the tip, all right? Okay. And it needs to be perfectly centered with the material. See that right there? It needs to be perfectly centered. And there's a couple ways to achieve that, but we don't need to know that quite yet. What we need to know is that, see this pin right here and this set screw right here? That set screw sits on top of that pin. And as we move the set screw up and down, the tool holder moves up and down in the tool post, all right? This lever locks it. Now I can't move it up and down anymore. And that's how we adjust our height. Okay, once again, there's a set screw in here. I forgot to grab it. It's on the other lathe. Hang on. There's a set screw in there, and if I loosen this lever, which unlocks the dovetail, I can move this tool up or down. So by tightening the screw, the set screw goes down, touches this pin right here, and it moves. So if I tighten the screw, right, it's going to move it up. If I loosen the screw, it's going to move it down. So if I back the screw out, right, it's going to come down. Okay. And I'm going to show you how to adjust to find center. Okay. You got to remember, always lock it. Now, this obviously is not the right direction. We need to be like this. But I think we all have a clear vision now of what that looks like. This right here, this machine screw right here, this Allen head machine screw, is how we lock the tool post from sliding in and out. Notice that I didn't, right? When I tighten this, I didn't even put my weight into it. Like I just snugged it up, okay? It's not going anywhere. Don't worry about it. If it does, you're doing something wrong, okay? All right, so we're gonna loosen this and we're going to find center, and I'm gonna show you this a few more times, so don't worry, okay? I'm gonna put this, center in here, live center in here. And I'm just going to move this over close, and I'm going to look to see if I'm in the ballpark here. This isn't perfect, okay? You're going to have to do some fine adjustment once you start cutting, but this at least gets you, so I'm a little bit low. I'm just going to give it a little, right? I tightened it to bring it up, all right? This gets you in the ballpark. This gets you close. You're still going to need to fine tune it a little bit, okay? Now, okay, what I'm going to do right now is I'm going to face this, okay? And I'm not going to use the power feed. I'm going to do it all manually. My spindle speed is at 654, which is great, like a nice medium spindle speed, all right? And we're going to talk about all that stuff, like fast spindle speeds, slow spindle speeds, and what they're used for on the lathe. And bring this up over here close, and I'm just going to, remember, I'm going to cut with the tip, right? So I drew a line in my mind along this face, and you can see that I am going to be cutting with that tip. So that's pretty good, all right? And I'm just going to tighten up my tool post, okay? And like I said, the process I'm going to be doing is I'm going to be facing this off. All right. So I'm going to bring this up close. I'm not going to touch. Remember, we never ever start with our tool touching our material, right? Ever. Like it's always away. Now, I'm not going to give you all this information all at once because it's impossible to retain, but I'm going to do what's called a touch off. I'm going to review that like 5,000 times. All right, but I'm not going to start with the tool touching the material. You never do that. I'm also not going to get in here with my face and be like, oh, is it close? Nope, nope. I'm just going to stand straight like I normally would. I'm going to bring the tool in close to the material here, and let's go ahead and turn it on. All right, and now what I'm going to do is I'm going to do what's called a touch off. And I'm just going to, actually I'm listening more than I am watching. I'm watching, of course, but I'm going to listen for the tool to touch the material. Okay, I'm going to back it off and watch my hands here. I'm just going to do a little bump. Okay, and now the nice, slow, even feed rate. All right, see that? Just a little bit. I'm not cutting too much, just a little bit. See the chip stuck on there? I need my brush. I brought it over to the mill because I needed to use it. All right, brush. I'm not gonna put my finger in there. No, no, don't put your finger in there. Move that. I'm gonna use a brush, okay? I'll brush off that chip so I can see. And I'm gonna face, and I'm gonna keep facing until that hole in there is gone. I'm gonna try and get in here so you can see it up close. Okay, now that hole is gone, so I'm going to say, okay, I'm going to turn it off. And move this out of the way. And what I'm going to do now is I'm going to put in the drill chuck, and I'm going to put in my center. So I'm just going to use this small center drill. It's a number 3, our 1/4" center drill. And put this in the drill chuck and tighten it up, okay? And now I'm going to get my tool post out of the way, get this up close, and I'm going to make sure I'm not crashing, right? See that? How I do that? Right? I'm gonna, right? Okay. With my hand. I'm gonna bring the tailstock up close, lightly lock it. And what I'm gonna do is I'm gonna center drill just up to this, up, just like on the drill press, right a millimeter or a 32nd of an inch before it goes straight. Hopefully you can see that. Okay. Okay, right there. I'm going to stop. You can see the angle. Now I'm going to move this tailstock out of the way. Move my chips. Always take the drill or the center drill, whatever's in there, out of the chuck, because if you drop it, this will break. Take this out. I'm going to go ahead and put in the live center. All right. I'm going to show you all this again. All I'm trying to do is give you a brief overview of the way that the lathe works. So we're going to pull our material out. Bring this up here. Go ahead and lock the tailstock. And I'm going to apply just a little bit, not a lot. Okay, I'm not going to force this into I'm just going to give it a little bit of pressure and then slightly snug up the ram lock. Okay. Now I'm going to do a operation called turning. And remember, now I got to move this because I want to be cutting with the tip again. So there we are. And hang on. There we go. There we go. Okay, so now we're all locked. Lever's locked, tool post is locked. And I'm just going to do the same thing, except now I'm going to be turning. Okay. And I'm doing all this manually. See that? Okay. One more time. Let me fix something here. I'm gonna turn off the lathe. It's all about setup. I gotta give myself a little bit more space. Keyword there, space. Snug that up, lock that. I'm gonna do the touch off again, okay? And I'll show you that one more time. There we go. Like I said, we're going to go over this a couple more times. So just understand the concept about what's going on, all right? We don't need to... Look what happens if I go too fast with the feed rate. Look at the finish difference. That's too fast. Way too fast, all right? Watch what happens if I go slower with the feed rate. So touch off. Touch, back it off the material, give it a little bump there, just a little bump. And if I go slower, it looks much nicer. Okay, just engage the power feed so you can see that. Oh, going the wrong way. So I need to turn off the machine. Move the lever. Sorry, there we go. Okay. move the lever the other direction, and now I can continue. And now you can see that the lever's moving automatically, and right, hands free. But I've got my hand on the lever in case something happens. You always have your hand on the lever. And I don't think I need to tell you, but absolutely never walk away. I mean, that's pretty obvious, right? Never walk away. So I'm going to stop the power feed about a 1/16 or an 1/8 of an inch away, right there, and I'll finish the cut by hand. Back this off, turn it off, and there you go. Okay. Possibly there's all kinds of things going on around in your mind about, oh my gosh, I can do this, I can do that, I can do... Yes, you can. These are the two very basic, fundamental cutting operations on a lathe. Once again, that's facing and turning, and supporting the material with a live center to turn. Okay? That's your introduction to the lathe. We'll be on this quite a bit, and I will go over this and over this and over this again. Okay? Great. So, I was going through yesterday's videos last night, and I realized that I forgot to tell you what the small number under the threads per inch number is. All right, so this small number, let's just take 40 threads per inch here. It says 0.0150, okay? What that is, yes, it's the feed rate of the power feed. Remember the power feed, get rid of this real quick here. The power feed is how fast the carriage is going to move this way or that way, this way too, right? This way or that way. But yes, it is how fast. But the way that it's calculated, and that's a little tricky to understand, is, well, actually it's not. This is how far the carriage is going to move per revolution of the chuck. Okay, one more time. Let's pick a different number. So it's smaller. It's an easier number to understand here. Let's use this. 16 threads per inch, and we're going to see 26 thousandths there. See that? 26 thousandths. Okay. That means 26 thousandths. That means that for every revolution, start here. For every revolution that this goes around, there's one revolution, the carriage is going to move 26 thousandths of an inch. All right? That's what that means. Why don't we take a look just real fast. Put this tool in here. I'm not even going to cut anything. Let's see what 26 thousandths looks like as we move. Oh, we're in coarse. We got to move it into coarse. So this is good. We're going to set the power feed up for 26 thousandths per revolution. So I'm in this column. I want to be in C down here. There's C down there, and I need to be in coarse. And then it says coarse. Use below 225 RPM. Oh. Okay, so that means I need to be below 225. So I just move this over to the, I'm in this column right here, and this white row, so that puts the chuck at 179. All right. Excuse me, I want to get some material real quick. Same material as yesterday, and that way I can turn the lathe on safely. I'm not going to cut anything. I just want to show you what that looks like. Okay. All right. You ready? Okay. So we're going 179 RPM, and you can barely see it, but it is moving. It's moving 26 thousandths per revolution. Turn this off. I can make it go up to, I'll put this in A. So that's going to put our, I put this in A down here. That's going to put our row into 4. Okay. Ready? It's going to go a lot faster. Why? Because it's 106,000. So it's going to go not exactly, but close to 4 times as fast. Right? Ready? Here we go. See? See that? Look up. Now you can actually see it going. It's moving now. Okay? So, there you go. All right, cool.